Welcome to the meadow census. As the flock gathers at dusk, our goal is to count the wildlife, to watch the geese fly overhead and see how the herd of deer spreads out along the river. But counting is only the first step. To make sense of what we see, we need to ask a statistical question. And a statistical question is specifically designed to anticipate variability in the data it collects. We have to let the data show its shape. Spotting this variability is the first step toward understanding any dataset. Analysis starts when we move past the raw count to measure the specific differences between individual subjects. Let's test this with two questions. Question 1. How tall is Maria? Question 2. How tall are the students in our class? We need to find out which one is statistical. Look at the left side of our screen. If you ask about one single specific deer, or one student like Maria, you get exactly one answer. It is a single static value. There is no room for the answer to vary. Now compare that to the second question. Measuring an entire herd, or a whole classroom of students, yields many different heights. Those values will naturally vary from individual to individual. How tall are the students in our class is the statistical question. A math problem with a numerical answer does not automatically involve statistics. Statistics requires variation across a group. Once we have a group that varies, we often want to find its center. Take this data set of geese on our number line, 2, 3, 3, 5, and 7. We can find the center using two different methods, the mean and the median. We will calculate the mean first. Step 1 is to add all the values together. 2 plus 3 plus 3 plus 5 plus 7 gives us a total sum of 20. Step 2 is to divide that sum of 20 by the total number of data points, which is 5. 20 divided by 5 results in a mean of 4. The median requires a completely different approach. We ignore the sum entirely. Instead, we arrange the data in strict numerical order and locate the physical middle. In this list, the exact middle value is 3. For this dataset, the mean is 4 and the median is 3. Both numbers describe the center, but they do it differently. The mean balances the overall mathematical weight of the data, while the median finds the exact positional center. They are two distinct ways to summarize the same group. Now it is your turn to test this. Here are two dot plots showing bird sightings. Group A is 2, 3, 3, 4, and 8. Group B is 4, 4, 4, 4, and 4. Pause the video and predict which group has greater variability. Let's check your prediction with Group A. We calculate its spread by measuring the distance from the lowest value to the highest. These values spread out from 2 to 8, which gives us a range of 6. Now look at Group B. You have 5 separate birds, but every single one of them sits at the exact same value of 4. Multiple subjects only provide variability if the values they yield are different. The range here is 0. Group A has the greater variability. Spread quantifies how far values vary across a set. Having variability depends on having different values, even in a large group. On our summary cheat sheet, everything comes back to one core rule. A question is only statistical if the answers vary. Mastering this prepares you for what comes next in statistics, describing data distributions by their center, spread, and shape. Anticipating, defining, and calculating variation is the essential foundation for turning a collection of raw numbers into a clear, meaningful story.